Hi, my name is Joe Cheng. I'm the CTO of Posit, and today I'm going to talk to you about harnessing LLMs from code in the service of data analysis. This talk is intended for people who know how to code in either R or Python. I'm assuming that you have used LLMs via something like ChatGPT or Copilot, Cursor, or Windsurf, but I've also assumed that you have not written code that calls LLMs, that you have not called LLM APIs. If you have a lot of experience using LLMs from code, um, maybe you're also just interested in Posit's take on these tools, in which case, welcome to you as well. So as we're getting started with LLMs, there's a couple of things you need to know right up front. One is that LLMs are generally accessible these days through HTTP APIs. There are other ways to call LLMs than through HTTP APIs, but I don't think there are any other ways that matter. This is the way most models are accessed today. Therefore, Posit has created packages that are designed to make it really easy to call LLMs through these HTTP APIs, and we're going to talk a lot about these packages today. For R, there's ellmer, and for Python, there's chatlas. So as we are getting started using these LLMs, let's just set our expectations correctly. First of all, you can expect that this is going to be super easy as we get started. Ellmer and chatlas are both extremely easy to use. These models, the best models out there at least, the best LLMs, are highly capable and they're getting better all the time. So if that's not your expectation, maybe because you haven't used these models in a while or you haven't sort of persevered through seeing them make mistakes, just know that they're quite good at a lot of things these days. And they are extensible. We're going to talk today about some ways that we can add our own behaviors and even add code, code in a way, to these models. However, these models do make mistakes, and they make them a lot. And not only do they make mistakes, they do them unpredictably, non-deterministically, which makes it even more frustrating. I think in summary, today, May 2025, these LLMs have a jagged frontier. I think that's a term you're going to hear more and more. There are things that they are surprisingly good at, even shockingly good at, and then things that they are really surprisingly bad at. So as we explore them, let's just expect to be surprised in both directions. So I have a couple of tips as well for how we should not approach getting started with playing with LLMs. First of all, you may have heard a lot about local models or open weights models. These are models that you can download to your own machine or your own server and run them. I highly recommend that you do not start with them and instead start with the very best models that the world has right now. Those are Claude 3.7 Sonnet, or actually as of today, Claude 4 Sonnet. OpenAI has a number of state-of-the-art models that are sort of have different trade-offs, and Google Gemini 2.5 is, I've heard, very good. The open weights ones like Llama and its derivatives, Quen, DeepSeek, they're just not as good as you have heard. I'm sorry. Sorry, not sorry. I also suggest that as you're getting started, don't start with non-public information or data. Don't start with your customer data. Don't start especially with patient data, my goodness. Instead, as you're getting to know these APIs, do it with low stakes, publicly available or just non-proprietary data. And only after you get a good sense of how to use these APIs and have a good sense for how they work, then you can think about security and data privacy and whether it's safe for you to use non-public data. So to get started, we're going to need to do a couple things. The by far most annoying part of this is we need to sign up for a developer account with Anthropic or OpenAI or Google if you want to go the Gemini route, and you need to grab an API key. It's pretty simple to do this if you just go to their site and sign up, but it does require a credit card. These sites generally will not allow you to make API calls without putting down a credit card and paying a few dollars. All I have to say is just do it already. I mean, I know this stops a lot of people from proceeding. It's just enough of a pain, enough friction, but it is really worth pushing through this step, and it really is not going to be a lot of money. You can do a lot of experimentation with just $20. That might last you a couple months of quite intense playing with these models. Once you have that API key, then you need to add it to your environment variables. And I have links that I'll drop in the description for doing that for both R and for Python. And then it's time to install an LLM client package. For R, there's ellmer, and for Python, there is chatlas. Just so you know, when you go to use chatlas, it may ask you as you try to connect, it may ask you to install other packages depending on what provider you're using. So just be aware of that. So this is sort of the hello world of using ellmer. This is the R version. You can see here, it's extremely short. There's just basically 2 lines of code here. The first creates a chat object calling this chat anthropic function and passes in the model that we want to speak with. This is Claude 3.7 Sonnet, and we are asking for the latest version. You could change this from chat anthropic to chat OpenAI and put in an OpenAI model identifier, and now you're chatting with OpenAI. In either case, you have this client object that you get back, or we often refer to it as a chat object, and you call the chat method on it and pass in your question, and you get a response. So in this case, summarize the plot of Romeo and Juliet, and it does so. Another interesting thing about this client variable is it is not just a way to ask questions, it is a way to carry on a conversation. So you can call chat multiple times, and each subsequent call is like the next question in this ongoing conversation. So here I say, now Hamlet. This is not just me asking context-free this model, hey model, now Hamlet. It is a follow-on to the previous question about Romeo and Juliet, so it knows how to answer with a summary of 20 words or less. This is the example in R, and then this is the example in Python. It is almost identical. You can see here that the capitalizations changed because I'm calling a Python constructor instead of an R function, but other than that, it's extremely similar. So a few things to know about ellmer and chatlas. Number one, they support many different LLM providers, pretty much all the ones that we can get our hands on. And this is really important because you want the ability to experiment with different model providers and just kind of see whether there are certain things that one provider does better than another. Secondly, you have the ability to have a chat and then take that chat object and just print it at the console or in a Jupyter notebook, and you'll be able to view the conversation history just by printing the object. And third, both ellmer and chatlas have built-in chat UIs, and in fact, they each have two built-in chat UIs, one for a web browser and one for the console, and I'll show you real quick how that works. So, for example, let's take that Romeo and Juliet example, and instead of doing this at the console, let's do it in an app. So we can say, so we can ask this question. And yeah, very convenient to be able to do this in a web interface. Or maybe instead of a web interface, you prefer a console interface. And I'm continuing the conversation here. I can say, like, how about Hamlet? And there you go. It streams the answer back. Okay. So super easy to use and designed to work really well interactively. But that's not actually that interesting, right? It's not that interesting for us to take a bone stock LLM that you already have a web interface for that you could just go to claude.ai. Instead, we want to be able to customize these models. And the first way we often want to customize them is by adding knowledge. So we want to tell these models something that they don't know from the factory. Just a quick couple of discouragements here. You may have heard a lot about RAG. I recommend that you do not start there. It is a very useful technology, but I don't think it's the one you should be starting with. Same thing, even more so with fine tuning. You may have heard this term. I recommend you do not start there either. When you want to add knowledge, the first place you should start is with system prompt customization. It is easy, it is effective, it's super quick, whereas these other techniques take a little bit of fiddling. So here is one example of adding some information via the system prompt. Okay, so what the system prompt is a way of us telling the model that for this interaction or for this conversation, these are the ground rules that I want you to obey. In this case, we're saying you're a bot that answers questions based on this expense policy doc. And I have an expense policy doc here that is actually for a fictional company called Example Inc. And really boring, right? It's saying here's what is eligible for expensing when you're traveling, when you're visiting clients, when you're buying office supplies. Super boring, but important to get right. So here I'm creating a string that says you're a bot that answers questions based on this expense policy doc. And then I put in some like XML tag looking things. This is just to organize all the lines I'm about to paste in. And then I put in this entire doc. I literally copy and paste this doc into this system prompt string. And then I have a couple more follow-up bullet points, cite policy, section numbers, and use examples when helpful. And now I can take that system prompt and pass it as an argument when I create a chat object. And now when I do that, the answer incorporates the knowledge from that document. So in this case, can I expense a programming book? It says, based on the expense policy, it might be. Ask your manager, section 3.4. Okay. So that is maybe not the most data analysis oriented example. So let's do one that is a little bit more in the vein of data analysis. So for this one, maybe you can relate to this experience that I've had multiple times where there's a data set that I'm very excited to get my hands on. In this case, it's the college scorecard data that the federal government puts out. And it has a lot of information about different characteristics of colleges and universities, as well as a lot of, I think, data from the IRS about the outcomes that students experience 6 years and 10 years after they graduate. So really rich data set. There's just one problem with this data set. So let me bring up what the data actually looks like. I've got this CSV here. And if we look in Positron, there are thousands of columns, and these are quite impenetrable column names. And the data dictionary is 800 kilobytes of Excel spreadsheets. I mean, it's just a lot. So what I've done here is I've taken that data dictionary, that Excel data dictionary, and I've used Claude Code to come up with sort of a condensed summary as a markdown file. And now I have created a system prompt that says, you're a bot that helps data analysis for college scorecard data. Do not attempt to analyze the data, but you can write R code. I'm telling it to use the readr package to read CSVs, and that assume that the CSV files are in the working directory. And then I read in the entire file I have that summarizes this data. And you can see it talks about hundreds of available variables. And this actually works awesome. So I'm able to run this example, and I can ask a question like, what are some demographic variables? All right, pretty cool. And by the way, note what we did not do here. We did not actually load the college scorecard data into the LLM and ask it to start answering data questions. We did not do that. We asked it to write code. And there's a good reason for that. Because on their own, the LLMs themselves are terrible at analyzing data. Like they simply are not suited for this task. So if you load up data into them in the format that they understand best, which is maybe JSON, they are actually not able to reliably do even simple arithmetic. In fact, they cannot even reliably count rows in a data frame. In fact, just today, I tried it with a small CSV, 299 rows, loaded it into Claude V4, the latest that just came out today, and it said that there were 216 rows. So we cannot trust them on their own. Instead, what we can almost trust them to do is have them write code that analyzes data, and sometimes even let the LLM have enough control that it can execute the code for you. And that is a much, much better way to have LLMs help us with data tasks. We want them to write code that then gets executed. So those last two examples only really involved adding knowledge. What they did not really involve very much of was customizing behavior. So let's use our system prompt again. And just by putting some different instructions there, we can have these LLMs act in quite a different way than just a general assistant. In this case, I'm going to say, like, you're a dungeon master for a Dungeons and Dragons style game whose theme is this expense policy, and I'm reusing this expense policy document. So if I go ahead and run that, and this time I'm doing it in Python. Oops. No, not like that. Now I'm running it in Python, and I can say begin. And it starts a ridiculous game of Dungeons and Deductions. Sure. Okay. So you can see here, I mean, this is really pretty bizarre that we can, just write two sentences and just get this completely different behavior out of this model. So far, all of these examples have just created ellmer and chatlas apps, and we've called them from either their built-in chat UIs or called the chat method from the console. But it's more common, I think, to take these customized ellmer and chatlas instances and build them into a Shiny front end. In R, we have a separate package called Shiny Chat that you can use to put a chatbot into your Shiny app. And in Python, there's not a separate package. There's a built-in component for Shiny for Python called UI.chat. And I will drop the links for the documentation for both of those in the description as well. It's very easy to do. With just a few lines of code, you can have ellmer and chatlas chatbots working very well. Because these are Shiny apps, they are super easy for you to deploy. You can deploy your apps with one click, or I guess one command, depending on how you do it. On-prem, we have a commercial product called Posit Connect. I imagine that many of you on this call already have access to a Posit Connect at your companies. Sometimes you may not even know it, but you do. And we also have a cloud-hosted service called Posit Connect Cloud. This is sort of the next generation of shinyapps.io, if you're familiar with that. I forgot to put it on the slide, but we also have open source on-prem hosting with Shiny Server open source. And just like Shiny apps are so easy to write and deploy that you could often, if you're pretty skilled at Shiny, or you use Shiny Assistant, which is our AI assistant for writing Shiny apps, it's often worth creating, deploying, using, and throwing away a Shiny app, all within a week or a day. It's so easy and so fast to do, and even more so with ellmer and chatlas because it's so easy to create these LLMs. We've definitely found that within Posit, we've had a proliferation of internal chatbots that just serve one specific purpose, and it would not have been worth the effort to create and especially to deploy a custom chatbot for that one specific purpose, like this expense report bot. But it's just so easy to do with this technology stack that we do it. A couple other ellmer and chatlas features that I want to show you. You have the ability to do image as input and the ability to do structured output. I'll come back to that in a moment. You have the ability to not just take a response as one big string all at once, but you have the ability to kind of take the response as streams of little chunks of strings. And if you know what async is, just know that both ellmer and chatlas work in synchronous or async modes. Just to show you how easy vision is, this is an image called photo.jpg. When I'm chatting with, in this case, Claude, it's as simple as instead of passing a string, or in addition to passing a string, you can pass the result of content image file, and you give it a file name. And Claude is able to see this image and tell you what the mood of the image is in a single phrase. This is what it looks like in R, and this is what it looks like in Python. Super easy to do. I will warn you, this is one of those jagged frontier areas where it's incredibly sensitive and nuanced to certain aspects of photos, and then other things like counting how many objects are in a photo. It just can't do sometimes. It's really surprising. So definitely worth playing with, though. I won't dwell on this too much. Just know that these models also often have the ability to not just give you unstructured text back, but to give you JSON objects that you can then use, to put into a database or to, code against for other reasons. So this is what it looks like in R. You kind of specify what kind of data you want back, what the shape of the data that you want back, and then you call chat structured instead of chat. And this is what it looks like in Python. Looks a little bit different here. We're using a package called Pydantic, which is a de facto standard in the Python world. And we call extract data instead of chat and tell it this is the shape of data that we want. And yeah, instead of getting a string, you get back some JSON that is very easy to use from code. The last topic, I don't have time for this, but I'm going to do it anyway. It's just such an important topic. Tool calling allows LLMs to interact with other systems. So instead of just taking text in and giving text back out, it gives the LLMs the ability to call out to APIs, to databases, the ability to execute code, to do things to your file system, just all sorts of things that can be possible. And that sounds a little bit scary and it sounds complicated, but it is not as bad as you think. So I'm going to try to explain how this works by first telling you how it doesn't work. This is how, when I first heard about this functionality, this is how I imagined it working, but it is not how it works. So one example of something that a pure LLM cannot do, an LLM is just a model. It can't get the current weather, right? You need a weather service for that. So in this case, let's say we have a user ask the assistant, what's the weather right now at Fenway Park? When I heard that there was something called tool calling that lets LLMs access other systems, what I imagined is somehow we would be teaching the assistant to reach out to openweather.org. It's a fictional service, but just pretend, and give me the weather for 02215. That's the zip code where Fenway Park is. OpenWeather would return the data as JSON, and then the assistant would incorporate that JSON into its response and say 65 degrees and sunny. Okay, this is how I imagine it working, but this is not how it works. Instead, it works like this. The user asks the question, what's the weather right now at Fenway Park? And it includes, along with that request, a description of a tool called getCurrentWeather. So it's not passing code, it is just passing metadata about a function. It's saying the name of this function is getCurrentWeather. It takes a single argument. That argument is a zip code, and it's a string. So the assistant, instead of answering with what the weather is, it instead responds saying, I would like to call this tool that you said was available called getCurrentWeather 02215. And it is actually the responsibility of the client, not the server, to go off and perform this request against openweather.org or however else it wants to fulfill the task of getting the current weather. When a response is received, Then the user continues the conversation by taking this response that the assistant asked for and sending it to the assistant. And the assistant now, it has the original question, it sees the request that it sent, and it sees the response that came back from the user. And therefore, now it's able to actually give a proper response back to the client, incorporating this data. So it seems a lot more complicated, but is actually much simpler. Basically, just to recap, the user asks the assistant a question and includes metadata for tools or functions that are available. The assistant asks the user to invoke a tool on its behalf and passes the arguments that should be used. The user invokes the tool and returns the output to the assistant, which the assistant can then use as context for its final response. It turns out this is an incredibly general and powerful way to extend the capabilities of these assistants. And anytime you hear the word agent used, which is a lot these days, just know that all of that is made possible by creating these tools and giving LLMs access to them. So another way to think of it is that the client can do things that the assistant can't do, like not only call out to things like a weather service, but to read and write to databases, to put files on disk, to turn the lights on and off in a smart home. Anything you can think of doing in code, you can empower the assistant to do. And we put the control into the hands of the assistant so that the assistant can decide when it's appropriate to use what tools and what arguments to pass in and what to do with the results. And it turns out that that's just an incredibly general and powerful capability, having that intelligence in using and coordinating these tools. So let's take that, everything that we've talked about so far. We've talked about ellmer and chatlas. We've talked about Shiny apps. We've talked about tool calling, customizing system prompts. We're going to put all of that together into an example. And this is an application that I have demoed before. It's a restaurant tipping app. What you're looking at right now does not involve any LLMs or AI. This is a simple Shiny dashboard that lets you, move some controls here, and it updates on the right. So what we have on the next tab is a new version of that desktop of that dashboard that does incorporate AI. And here we have we've replaced those controls on the side with a chatbot in the sidebar. And this chatbot, you can ask it filtering questions like show only male smokers who had dinner on Saturday. And instead of having to move a bunch of sliders, you just say what you want in plain English. And what this application does is it doesn't ask the LLM to populate all these outputs on the right. I would never trust an LLM to do that. All we are asking the LLM to do is to fulfill the user's request here by writing SQL. So this SQL is passed as a tool call to the rest of the Shiny app. The tool is called update the dashboard with this filter. And you can see here that we've shown the SQL in two places. And the thing that's key about this is that if the SQL is right, then everything below it is guaranteed to be right. Because the only thing that this chatbot has the ability to influence is what is the SQL that drives the rest of the app. The rest of the app is just normal, Shiny reactivity. All of this code is just normal, Shiny, deterministic code. I didn't mean to hit that, but this is just showing that we have a separate feature where we use the LLM to explain what you're seeing in a plot. Sorry, what I meant to do was hit this triple dot button and show that like this simple reactive code, it still works. Well, we've narrowed it down to a not very interesting subset, so these are pretty boring views. So, but the point is, this is all using the pieces that we've already talked about here with ellmer and chatlas and tool calling and system prompt customization. We have the ability to embed really intelligent agents into our Shiny apps and deploy them. I demoed this application last year at PositConf, and at the time, this was just an example that you could fork if you wanted to, and replace everything to have your own data. Since then, we've made things a lot easier by creating this package called querychat. This is for both R and for Python, and it's designed to make it dead easy to take these kinds of sidebar chatbots that return reactive data frames using SQL. So it's extremely easy to build your own version of this app with your own data, your own visualizations, and your own downstream reactives. Again, that's called querychat, and there's documentation for both R and Python here. Well, that's all the time that I have today. I hope that over the last 30 minutes, you've seen how easy it is to get started with this technology, how easy it is to play with LLMs and ask them to do different things, and just see how it works out. And now is really the time for that. Now is the time to play with these technologies. They are coming. I mean, they are here. And there is a tidal wave of change that's ahead of us. And the best thing I can recommend is that you be on the forefront of that change by understanding how these things work, what they're good for, what they're really terrible for, and help guide the future of how we should be using these things, especially when it comes to data analysis. There's so many more things happening inside of Posit, packages and tools and services that we are doing, that we have already done and released. So I encourage you to stay up to date by following the Posit blog, Tidyverse blog, Simon Couch's blog. There's just so much interesting stuff happening around Posit, around AI. So we have a lot more interesting announcements coming soon. So stay tuned. And with that, let's go over to Q&A.